All right, I think it's 11 o'clock, as best as I can tell. Thank you for coming to this presentation on running OpenStack at the core and at the edge. We'll probably wait a couple of minutes till we get a couple more hecklers in the room. Okay, there's one.
Yeah.
My name is Amrit. This is Fred.
I'm Fred.
And both of us are with Verizon. I've been working on OpenStack since approximately Atlanta, so call that 5 years. This talk is going to tell you something about what we at Verizon have done with OpenStack, why we use OpenStack, and where we see OpenStack going. I understand we have 40 minutes. We have stuff for about 30, so questions anywhere along the way.
Spacebar.
Oh, spacebar.
Yeah.
Oops. So I have one slide. This is the slide. While it's up there and you guys are reading it, Verizon, we operate a fairly large cloud, as you can imagine. Some years ago, we decided that we were going to do this based on OpenStack. And I'm going to start by describing what our cloud looks like today, where we see it going, and Fred's going to pick it up from there and tell you about some of the things which we have to do, a significant precondition for us to be able to actually deliver that cloud. So our cloud as it runs today, we have a core and we have an edge. And this is not a public cloud. This is not a cloud like, don't compare it with Amazon or something like that. This is a cloud where we literally run the services which we have to make these things work. We have locations in the core. We have locations in the edge. And our definition of edge at this point is probably 50 places in the US where we have resources for all of our bearer traffic. And we have locations at our core, which is our network equipment centers. And light is something which we have in international locations for some of our corporate customers. Each of these locations is OpenStack in slightly different ways, and I'll show you how that is. Where we want to go in the future, though, is that we want to have one converged cloud, and the notion is that there are applications, there are things which we want to run in multiple locations, but we want it to be from an end user, from an applications perspective, they should all look similar. It shouldn't matter whether I'm running that application at a core location, at an edge location, or in the future at a far edge location, which we'll talk about. The objective is we should be able to move that workload seamlessly from place to place. We have infrastructure at different locations. Today, for example, if you want to spin up a VM, the typical way in which you would do that is by leaving the scheduler to decide which compute host you want to put it on. On the other hand, we have requirements where we want to be able to say, I want to spin up a workload which I want to be so many milliseconds away from a group of people. I have a requirement where I want to spin up a workload where I say it needs to be in this location and that location because they're peer locations for some telco reason. So we're building a different set of smarts into how we move workloads to these locations. And we need to be able to pick that really carefully onto all of these in one common experience. And the last thing is a workload in one location should be able to move seamlessly to another location without any disruption to your service. I'm right now on a phone call. If I want to have this phone call continue to stay up while services are moved from point A to point B, that's the kind of service which we're looking for. Gentlemen, is that general idea, good idea of what we're trying to do with all of this? Say yes, no. Is my microphone working? OK. So we talked a little bit about our applications. So let's dig into that a little bit more, because it's kind of important to understand that there are very, very different kinds of applications in our cloud. Some of them are data movers. So every phone call is a very, very large volume of traffic from or in aggregate, it's a significant amount of traffic. And the really important thing about that is there's not a whole lot of persistence, but we're very, very, very concerned about bandwidth and latency. The last thing you want to have is a variable latency on that network. On the other hand, we have other applications which do things like messaging. Again, there's a lot of messaging traffic, but there we're interested in bandwidth and performance. But you know what? Latency can change a little bit. If your text message makes it 50 milliseconds as opposed to 60 milliseconds later, yeah, it's not going to be the end of the world. But the same can't be said for voice traffic. And of course, we have the traditional back office workloads as well. So billing and things like that. Those are 3 classes of things which we put on our cloud. But for each of these, there's also other requirements which we have. For example, there's geodiversity. How do you keep the most stable network up and running at all time? So how do you have these applications in a geodiverse way? And how do you have them in multiple locations so that you can have disaster recovery covered as well? How do I have the application near to where you are so that you can have your phone call with the best quality and so on? Those are some of the things we have to architect for today. But if you were to look at a traditional cloud, and this is just a representation of what a traditional cloud would look like, the things on the right, that's where you and I are going to be. We have our phones, we have our tablets and things like that, the cell phone network. But if you look at a typical cloud, let's assume it's, say, Amazon or something like that, all of your resources are between 10 and 100 milliseconds away from your end user equipment, from this gizmo. And that's not always a good thing. So the place where we want to go is to be able to say something slightly different. We have our data center, we have our network. These are our core locations, for example, and those are our edge locations. In the future, we're going to have stuff at the far edge. And each one of these little gear representations there is some cloud resource which we make available to you. There's small resources all the way to the far edge, and there's resources all the way back here. But the idea is you can orchestrate your application in any one of these places depending on what your application needs. If you're doing augmented reality or virtual reality or something like that, running that service out here probably doesn't make sense. You want to run it all the way out at the far edge. So the idea we have is we have compute abstractions. In the core, you could have a bare metal or a VM, a heavyweight kind of thing. As you get closer to the edge, you may talk about VMs and containers, because those are the kinds of things you would put in the edge location. When you get all the way to the far edge, you're talking about things which are containers or serverless. From our perspective, that's where we want to get to. The kinds of workloads which we're looking at require this kind of diversity in order to be able to deliver the kind of services which our customers require. That's basically where we're at. Now, in order to get there, and a small mention about data, since we are talking about containers and serverless, it's important to point out that while there's a whole notion of persistency in the core, there's less of it all the way at the far edge. But you look at this very quickly, you'll realize that each one of these is going to become a small piece of OpenStack or an OpenStack deployment. And for those of you who've operated OpenStack, you'll realize operating one OpenStack is hard. Imagine operating thousands of them. So the real thing which we're working on, and that's where I'm going to hand it over to Fred to talk about it, is how do we actually look to make something like this work at real scale? So, Fred?
Yeah. So I think, again, the issue is, again, we've got a huge set of applications. They're distributed all over the world. They have all different formats of VMs, containers, serverless. And we want to control these things as a single entity and really control them as services. And in order to make this work in any real way without having an infinite number of people to manage all this is to deploy some kind of automation. And I'll talk a little bit about kind of what that means to us and the value of all this. Today, we're spending a lot of time in just trying to manage the individual elements. And we treat these elements very much as pets. And our goal is to eventually try to move away from those pets and make them less of pets and more the kind of the classical cattle environment. Without having some of the applications be re-architected to support this, we're kind of waiting for our vendors and pushing our vendors. And I'll talk a little bit about how that we're pushing in the next slide. But again, from our perspective, what we really need in this environment is to think about these environments as generic services that we might be made up of many network elements, multiple network functions, multiple containers that are distributed across a worldwide deployment. Some of them might actually be off of our infrastructure. There might actually be components that are in one of the public cloud environments, AWS or Azure, Google kind of thing. So how do we do this and maintain some control of the environment and what we're trying to do? So I think, again, the kind of top environment here, we want to automate slowly, or kind of we're going to necessary to automate slowly and automate some of the deployment characteristics, slowly enable the automation of the monitoring analysis, and then get to a point where we can actually do a closed loop assurance of this whole environment by monitoring, doing some correlation about what the events are causing, and causing some action based on those events. And again, this is across our worldwide network, has a large scale, and kind of defining what would be a policy for how it would arrive at a root cause and then arrive at an action is a challenge. Again, just some of the evolution that we see in some of the network elements, network functions. What we started with in our legacy environment was all the generic code as it was initially running on the vendor's hardware. The vendors had packaged that up as one giant VM. It would basically be the equivalent size of one of our compute servers, and very hard to schedule, very hard to share the resources across these large VMs. We're slowly migrating that to decomposed services, microservices in the nomenclature, and be able to individually deploy, individually manage the microservices, which might be either small VMs, might be containers, might be serverless compute entities in this environment. And so this is what we're working with our vendors on and working internally to try to make these network functions be more easily composed, more easily deployed and managed. Just some of the automation requirements. Again, we're looking at how do we actually arrive at something that we can automate our network with. So we started looking at what are our requirements to get to this nirvana of having complete automation. And kind of went through this list of pieces here. And then we looked at these things and added, well, here's a scaling part as well, that we actually have to deal with a large number of scale and distribute it across kind of a core environments that might be in a centralized data center, scattered edge locations, even out to potentially at the radio towers as you might go along. And then even at the back end, and having some public cloud environment. Taking all these requirements and we try to figure out how do we actually get this. And so one of the areas we started investigating in is to look at ONAP. It's currently a project that came out of AT&T and working with China Mobile and Huawei, and a combination of eComp, OpenEComp, and OpenO. And there's components from all this various industry groups, various vendors, various operators. Verizon has joined ONAP this past year, and we're starting to contribute this. And some of the reasons why we think this is a reasonable approach and some solution for this, and is basically there is a reasonable set of components to match our requirement. And while it's certainly not it's not a completely usable system today, we see that there's a significant architectural alignment with what we're looking at. And we see there's a lot of opportunity where we can contribute teams, contribute code, contribute to requirements, guide various components of this along to a place where we actually can use the ONAP, either individual components or all the components in entirety, and gradually adapt that to manage our network. Some of the areas that we plan on working on. So we have a development team that we're actively starting to engage and contribute. And we're slowly adding to these functions. So one of the, if we're going to run this as a automation suite in our network, we have to have an environment that is scalable, is reliable, highly stable, that we can deploy in our existing network. Will provide us all the reliability that we need. And if you think about this as a closed loop environment that has to react to the services and events as they occur, it becomes, in fact, the critical item in all of these deployments. And so which kind of points that it has to actually be more reliable, more available than even some of our deployed VNFs. It also has to work on more than just the virtualized environments. We need control of all the physical environments in between and be able to monitor all the physical elements, all the network components that are between the virtual elements, and be able to correlate and act and control all of the different pieces. One of the things that we found kind of lacking in our current path, we're very much kind of attached or going along the ETSI NFV Nano path, and we have deployed or asked our vendors to work with and be compliant with the ETSI Nano configurations and interfaces. And so that's kind of one of our major requirements for ONAP, and that isn't currently supported in the ONAP environment. There is some motion towards that, but it's not currently in there. So that's, again, another area where we intend to spend a significant amount of time, is to align, merge some of the ETSI interfaces into ONAP and operate those in conjunction with the existing services and existing interfaces. And then, again, in order to manage some of the network functions that are physical elements, we're in very much of a brownfield environment. We need to be able to control, monitor, configure all of the interfaces in between, and that has multi-domain network elements from optical to various transport through various firewalls, routers, load balancers in between. And we need to treat that as a unified entity that we can control, scale as needed to support the VNFs. And we went through faster than I thought, but were any questions or anything that I can answer for you? And Amber can answer some questions as well. Any questions? Yeah, so there's that's a ways away. There is some kind of unified radio environments that have compute and radio integrated inside the towers, or could be in the towers, and that's an area where it's probably not a generic processor running in the tower. but it's something that would be more targeted at running some virtual RAN kind of environments that you could deploy some radio-specific optimization, radio-specific control elements in there. So it probably is closer to thinking about it as a physical element, but it is a compute thing that you could actually deploy a new version of the software and treat that as a virtual element. And then probably closer to a container at that place.
But the goal would be
Right. It's completely, I mean, that would be the end case. But it's probably, again, various steps along the way. There's, it really is a trade-off between how much you would deploy and the management cost of deploying something that far out versus what the control you get from having that. Latency, I think Amaris was talking about, latency would be the key driver to put something out there. And we'd have to look at what the cost of maintaining that the control and compute elements that far out versus what it would cost to manage that and what the advantage we'd get in the latency aspects. Kind of moving back a step from there would be deploying something at a hub location near some towers, again, within reach of milliseconds of that, and be able to have a lot more of the kind of the cost scale is better because you can deploy a rack or half a rack at this hub location and still talk to the radio as over open protocols.
So some of these costs which we're talking about are for traditional telco workflows like phone calls and things like that. Let's talk about maybe some slightly newer workflows where in a situation like this, where all of the UEs, which are your user equipment on the far right of the picture, an important consideration for where you place the workload is going to also be where the data needs to traverse. Let's assume that there are multiple people, like people here in this room who are all collaborating on some content, which let's assume is coming from out here. Having an application which is being shared by all of us running here literally means we're schlepping the data back and forth for no good reason. On the other hand, if I can push, take the workload to the place where it's most needed is really what we're doing, because we're trying to optimize for latency, yes, but what's the other side of latency? It's how much do you have to move the data back and forth. So there's a whole new class of workloads where this is going to become really important.
Yeah, and these are all just cost trade-offs of where do you run things versus latency advantages you get versus the cost of transporting data. All those things are interesting variables.
And there's also the issue of diversity, right? So you can get really low power equipment running out there, which may be a very cost-effective way for you to do something where all you need is something like literally a small serverless activity, as opposed to if you literally need to have heavy-duty computing, you may want to put it out here. An example of one of these kinds of things is if you're doing augmented reality with a connected device, it's not the edge, but really the boundary of that is the augmented reality device. If I wanted to do that computing on that device, there's not enough battery power. What if I were able to take just the compute-intensive part of that and throw it into something which is really close by? That's the class of workload which we're looking at where something like this will become interesting.
Mm-hmm. Yeah. Any other questions?
Would some of those workloads use GPUs?
Yes.
Certainly for AR,
Absolutely.
VR, yeah.
Absolutely. There's classes of workloads where we would use GPUs, any kind of acceleration. At the end of the day, it's how do you get the right tool at the right location to do the right job. The issue which the traditional cloud has is you can have any color as long as it's black. You can have any compute resource as long as it's in my data center like 200 milliseconds away. That's really good. I'm sure you can drive the cost down really crazy. But have you ever tried to do augmented reality where your frames are refreshing once every 100 milliseconds? You will get a headache. Mm-hmm. So if you have to do GPUs and things like that, yeah, we'll put it out there. Yes, sir.
So is Verizon planning to offer those kinds of compute services at the edge?
You mean like third parties? We haven't gotten a business decision there. It's certainly possible. We haven't gotten that conclusion yet.
Yes, sir.
Can you just comment on the notion of hybrid for you guys? I mean, are you thinking about public cloud or radio frequency or talking about
Yeah.
networking?
Yeah. So I'd say all of those. And see, there's certainly things that are amenable to running in an AWS kind of cloud, as long as we have some connectivity to that. Some back-end computation bursting in some of our marketing campaigns, any number of things like that would be reasonable to extend out from our private cloud into a hybrid cloud environment. If we can provide a secure interface and connectivity between a VPC inside one of these environments and something inside our network, there's certainly a useful path there.
It's literally the right resource for the job. Yeah. If it's something which is where cost is really important, or if I suddenly need to spin up, let's say, 1,000 nodes to do a Hadoop job, and it's cost effective for me to push the data out there, Amazon's a perfectly good alternative. It doesn't have to be OpenStack all the time. Yes, sir.
So, Brad, I know that you've got both, mobile services and enterprise services in the cloud infrastructure. I'm thinking as you go maybe toward the far edge, I'm wondering if those are going to start blending a little bit.
Sure.
Are you looking at that as mostly just a provisioning?
It's provisioning and control aspect. I mean, if there's a bunch of prerequisites to run something like an enterprise application out at the edge that's not targeted at running our infrastructure data path. It's running something out there. There's a bunch of prerequisites, but it's feasible, and to the extent that we do something like an SD-WAN kind of thing sitting someplace closer to the customer, I think is certainly something that would be usable.
Others?
Yeah.
We still got 13 minutes. There's got to be questions. Otherwise, we're just going to stand here. You are.
Okay. Well, thank you very much.
Thank you.
Appreciate your time.